All right, so here's a thing pair share. Now, because you're still learning the process of hypothesis testing, usually for thing pair shares, I wouldn't put calculator functions here, um, screenshots of calculator functions, but you're still in the process of learning this, so I've included these here. You want to be able to do these hypothesis tests, of course, without any prompting of which calculator functions you need to use. So you should continue to practice these over and over and over again, so that you learn, like through muscle memory, which calculator function you need to use and when, and to do that with a lot of confidence. Okay, so let's look at this one. A sleep study for randomly selected adults collected sleep time. The unrounded statistics for the study were a sample size of 12, a sample mean of 6.833 hours, and a standard deviation of 1.9924 hours. Conduct a hypothesis test with a 95% confidence level to test the claim that the mean amount of sleep for adults is less than 7 hours. Assume the population is normally distributed. Justify your analysis with your observation of both the critical value versus the test statistic and the significance level versus the p-value. All right, so let's begin this. Step one, and identify our given information. So let's see, blah, 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 blah. The unrounded statistics. Okay, so this one, a lot of it was just handed to us. We didn't really have to interpret what was written into anything else. So that's kind of nice. Now it says conduct a hypothesis test with a 95% confidence level, which means we're going to have a significance level of 5% or 0.05 to test the claim that the mean amount of sleep for adults is less than 7. So the mean amount of sleep for adults is less than 7. Okay, that is our original claim. All right, that's nice. Um, all right, so what's missing here is what we're missing is the population standard deviation. That's unknown. So this is going to imply that we need to use the student's t distribution. And therefore, we're going to need degrees of freedom. And so that's going to be the sample size minus 1, which is 12 minus 1, or 11 degrees of freedom. All right, let's move on to step 2. Here we go. So this is to set up our null and alternate hypotheses. So we've got the inequality mu is less than 7. That is our original claim. The complement to that, the complement to less than 7 will be greater than or equal to. And because this other one has equal to, that'll be our null hypothesis. And our original claim is our alternate hypothesis. And the sign of the alternate hypothesis tells us the direction. And because it looks like an arrow pointing to the left, this is going to be a left-tailed distribution that we're dealing with. Step 3 is to calculate our test statistic, which will be t-test, because we're dealing with a student's t distribution, and a p-value. And again, if we were going to manually calculate this, we would use this formula. Okay. And I guess just because we have this here, I'll go ahead and fill in these values in case you're curious. Okay, like that. But I'll hold the suspense as far as what this is going to end up being. Okay, because we're going to use the calculator for that. So here our value 7, sample mean of 6.833, sample standard deviation of 1.9924, sample size of 12, and our alternate hypothesis is mu less than 7. Right there. Okay, so we're going to have 7 there, less than 7 there with numworks. Sample mean of 6.833, sample standard deviation of 1.9924, sample size of 12, significance level of 0.05. Scroll down a little bit, a little too much. Okay, so so let's go ahead and calculate these. So let me hit home, distributions. Oh, it just brings me back here. Okay, so let me backtrack. So distributions, want students T. The degrees of freedom is no longer 14, it's 11 now. And this is left-tailed, so I want the area to the left. Wait a minute. No, I want to do tests. I'm sorry. I've been doing this a little too long today. All right, we want to do a t-test. I'm sorry. So we want to go to inference. Tests. Tests of one mean. T-test. Okay, so now we're going to have 7. And the alternate is less than 7. Oops. Let's see. Did I do that right? Yes. Okay. So go down to next. We are going to input statistics. All right. We've got a sample mean of 6.833. Sample standard deviation of 1.9924. Sample size of 12. And a significance level of 0.05. So before I keep going on that, let me go to the Texas Instruments. Okay, stat, tests, second one down. Okay, we're putting in stats. So let's see, this is going to be 7, 6.833, 1.9924 with a sample size of 12 and less than 7 for the alternate hypothesis. Okay, calculate. Okay, we get a negative t-test statistic. Let's come down here and hit next. Okay, negative 2.90 and 0.388 for a p-value. Let's go ahead and write that down. So we get a t-test statistic of negative 0.2904 and a p-value of 0.388. All right. So let's go now to the next step, which is on this page. Okay, step 4. So this is to set up the distribution. And let me carry my values over from the previous page. So my test statistic was negative 0.2904 with a p-value of 0.388. Okay, So we want to draw a student's t distribution here. And this is left-tailed only. So this is going to be my negative t critical value, or the area to the left. That's my significance level, and that's 0.05. Confidence level, 0.95. The region over the tail, that's our reject the null. The area above the confidence level is fail to reject the null. Okay, we have a t-score of 0 at the center of the distribution, so I'll put that in. And now we want to calculate this negative t critical value based off of this area. So let's go ahead and do that with inverse t. So inverse t calculates area from the left. So that's going to kind of match up well with what we've already got. And then we'll use the student's t distribution on the numworks to get that value as well, which is what I was accidentally doing first. All right, so let's quit out of this. Let me clear that. And we want to go to inverse t. So that's going to be in our distribution functions here. Go to the fourth one down. We have an area of 0.05 with 11 degrees of freedom. Okay, negative 1.796. Okay, let's go back to numworks. And let me click home. Go to distributions, students t, 11 degrees of freedom. And I want the area to the left to be 0.05. And that gives me negative 1.96. Okay, so this negative t critical value is negative 1.796. All right, so where is our test statistic relative to that? So our test statistic is negative 0.29. So negative 0.29 is going to be, somewhere between 0 and negative 1.796. So this is going to be our t-test statistic, and that's negative 0.2904. And so from this spot on the number line relative to that spot on the number line, we're just going to go straight up from there, and that leads us to fail to reject the null. And the area alongside our test statistic, that is our p-value, that was rather large at 0.388, or about 40%. And we can see, half of the distribution is 50%, right? All of this in yellow is 50%. So, having this t-test statistic kind of close to 0 and it being close to 40, that makes sense with our picture here. And now, of course, if you compare the p-value to the significance level, okay, you can see the p-value is larger. And the rule is if p is smaller, you reject the nuller. Okay, but because the p-value is not smaller, we're going to fail to reject by comparing areas. So we're kind of running into the same conclusion here. So step 5 is to kind of put together what we've got. So we've got fail to reject the null, and the alternate hypothesis was our original claim. So let's see here. If we come down and we fail to reject the null, and the alternate was our original claim, then this will be our outcome to write our conclusion. So start writing it. There is not sufficient evidence to support the claim that the mean amount of sleep for adults is significantly less than 7 hours with a 95% confidence level. And that is our conclusion. Last thing I want to do is, I almost kind of forgot, but I do like to put in the values here for the calculator screenshots to help you. Area to the left of 0.05. Okay, yeah, and that would give us a t critical value of negative 1.796. All right. All right. So, hopefully, by now, if you've been watching the other examples, you're starting to see a rhythmic pattern. We just keep repeating the same pattern over and over and over again. But there are subtle differences, and those subtle differences matter. They kind of change the values and the structure and a little bit, especially the calculator functions that you need to use. That changes as well. And so all of that comes from how closely you pay attention to all the information that's given in the word problem at the very beginning, right? Or in order to carry down all the way and get the correct answer here at the end. Right. My poor laptop. Okay. All right. Let me know if you have any questions.